Hot air, cold air, what's the difference? Hi, I'm Barbara Tharp. Today we're going to investigate the behavior of warm air and cool air. Do they really occupy the same amount of space? With that in mind, we'll need some materials. What might they be? To begin with, we'll need a pitcher to collect some water. We'll have to have a candle for heat and matches to light the candle. This is for the teacher. We'll also use clear cups. We'll need some sort of a bowl or petri dish to dip the can in, goggles, and crayons to use for prediction. But I want to explain two tips here. First of all, we'll use bubble solution, but the bubble solution, you can use purchased bubble solution, but you can also make it very easily using a gallon of water, or almost a gallon of water, with a cup of either Dawn or Ivory and a fourth a cup of glycerin that you can get at the drugstore. Just put those together, leave it in the jug. Over time, it just gets better and better. And we also will need a can. This is the can that we will cover with the bubble solution. Now, the can is just a regular soda can. We just cut it off. We'll use about the same amount of space for each cup that we cut off, so about almost a half the can. What we'll do is you just cut it with scissors, and if you're worried about cutting yourself, you can also, where the students cutting themselves, you can put masking tape around the edge as well. Works either way. Those are the basic materials you're going to need to activity today. Safety considerations. Well, at first I talked about the fact that you don't want the kids cut the can. Basically, you cut the can, and unless they jam their hand down it, they're not going to have a problem with that. You're also going to use safety goggles because you don't want the bubble solution in their eyes. Make sure you mention again that they don't need to taste anything, and make sure that you follow all of your district and school safety rules as well. So now we've looked at a little bit about the physical properties of air. We're going to look at how does air behave. How does air behave? Well, anybody know anything about how air behaves? What does it do?
It doesn't have a shape.
It doesn't have a shape. It takes on the shape of... With that in mind, the next thing we're going to do is we're going to look at, since it takes the shape of whatever container, what does it do to take the shape? Why does it take the shape? Okay? With that in mind, you've got 3 cups. Okay? Of the 3 cups, each one of these, this is water. The brown part, or the gray part's water, and those are cans. Here's a can. It's just a soda can. And if you believe it or not, when you cut, you can take your knife and cut a soda can off now they're just really thin. If you're concerned that your kids might cut themselves, you can cut the cans. Unless you've got some person who's going to go like this, you're not going to have a problem. If you think you're going to have a problem, you can put masking tape around it. It'll still work fine if you want to do it that way, but it works fine either way. Well, what am I going to do? This is going to be my container of air. Okay? My container of air. Now, how am I going to seal my container? I'm going to take bubble solution. We have bubble solution in little petri dishes, and you can put it in a cup. You can put anything you want to. But you put the bubble solution in, and you dip it in, and then you lift it up, and what's going to happen? You're going to have a film of bubble solution across the top. Okay? Now, once you have that film across the top, it's going to sit there until it pops, right? But what would happen if you applied heat or cold? What would that solution sit the same place, or would it do something different? Now, students aren't going to know the answer to this, most likely. So what I have them do is I have them take a marker or crayon and make their prediction. And I say marker or crayon, and you all know why, right? Otherwise, they're going to be wrong, and they're going to erase it. Prediction's not wrong, but we have to make them understand that that's just their guess based on what they know, okay? So I want you to take some marker or something, and where it says cold water, what would happen to the surface of this bubble with cold water? Is it going to go up? Is it going to go down? Is it going to stay the same? Okay? Because you're going to float it like this in cold water and see what happens to the volume. All right? So you're going to draw cold, room temperature, and warm.
When we got the can.
Well, she said this is
We're just going to predict? Okay.
We have a good question over here. Someone said, why can't you just use plastic? Why can't you use plastic cups? Think about heat transfer. What happens? It's not going to transfer in that plastic, is it? But it's going to transfer in the aluminum. But that's a really good question, and kids are going to wonder about that. And what you could do, if you've got time, it'd be really cool to let them try both ways and see if anything happens, right? Now, when you do this, you're going to do it with the hot water, room temperature water, cold water, and then you have a candle, okay? The candle, you can light the candle, and you can sit like so We're going to sit the candle on wet paper towels, right, for safety. And once you light it, and you can just hold it because it doesn't conduct enough heat to burn your hands. Okay, so you can just hold it right up here. And if you've got kids that you can trust to do this, wonderful. If you want to do it as a demo, that's fine too. I think by 5th grade, lots of times they can do it, but sometimes there's a rule in the classroom about fire. So, you have to decide yourself. If you want to be real safe, it's easy to just take a pie pan, put water in the pie pan, set the candle in the middle of it, and then if anything tips over, it's just going to go out. So those are some ideas that you can use. But what you're going to do is the 3 different ones, and then the candle, and watch what happens to that surface.
Yo creo, ¿no? O sea, no sé, que
va a reventar la bomba, ¿sabes?
Y como tiene la tensión superficial, la va
a reventar.
Y va a empezar a subir.
Sí. Pero lo que sucede es que el aire, los gases, con el calor incrementan su volumen.
Se expanden.
O sea, no solamente extienden, sino que incrementan su volumen.
Es cierto,
¿verdad?
es cierto.
Y
Sí, están más sueltitos.
All the way around, even over here?
Mm-hmm.
Yeah.
Oh, it went way down over there.
Which one is the warm water?
This is room temperature.
Okay, you want to do room temperature next since that's
Yeah.
on here next?
Be very careful not to touch the bubble.
Yes, ma'am.
Look at it. Look. Wow.
Tell me what happened when you put the water in the cold. Just show me with your hands. Did it go up or did it go down? Down. So you can have the kids, it went down. What happened when you put it in the room temperature water? So they can show you like this. And when you put it in the warm water, it went up. You've got a container of air, and it's just that much air. And with that much air, if it has less energy, it's moving less, so it shrinks, right? And so I sometimes have kids stand. Anybody ever done that? Can be dangerous. I have y'all come up here and let's do it. It's just you 4 come up here. Okay, I want you to model. They're going to model what happens when we put that container of energy, that container of air. When we put that container of air in cold water, show me what happened to it. They are just huddling up, aren't they? Okay, they don't have a lot of energy. Oh, that's good. Okay, now they're going to go room temperature. What happens to them? They're just kind of blobbing around, right? Okay, now we put it in the warm water. What happens? They're just... Okay, now we put the candle under it. Woo! They're everywhere. Okay, that's what really happened. Isn't that cool? All right, thank you guys. You guys are good sports. Okay, that's what literally happens. That's what literally happens with that, because you've got a confined amount of air, right? And it literally really shows them that it is moving somehow. And there's not more air in there, right? It's just moving farther apart because it doesn't have a definite shape. Okay? Make sense? Now that you've seen the activity and how to do it with your students, let's look at some extensions. They can blow bubbles and watch where they travel. Also, you might want to ask them, do differences in temperature affect the distribution of dust and other pollutants within the room? What's happening? How do temperature differences affect air movement on Earth? Enjoy.